Okay, this topic is usually, this is the length of an arc, and Matt, you should get your sheet out, it's ivory colored. And this is a BC topic, and it's usually with a calculator, because when you get these arc lengths to figure out, you can't integrate them, not easily. Okay, so we're going to do both Cartesian and parametric equations. And so how do you find the length of a curve? And this is going to be related to vectors, which is kind of nice that it all connects. Thinking of a curve and portioning, I think it's partitioning into small segments, how would you find the length of one segment? Okay, so suppose the curve is described parametrically like this. So I want this length. Sorry, I want that length. Well, if I make it small, right now it's big, but if I make it small enough, if I zoom in enough, what will this curve look like? Straight line. And so you know what? You know x equals f of t. Y is equal to g of t. Right? Well, I want the length. Yeah, but I'm not gonna just do that. I'm gonna do the derivative. Or am I doing velocity? No. So x is equal to f of t. Okay, right? G of t. I'm thinking velocity. Sorry. And so by Pythagorean's theorem, L squared is equal to g of t squared plus f of t squared. And so L is equal to the square root of that. I think I'm doing it wrong though. It's just Pythagorean's theorem. But actually, that's not right. That would be just one little segment. I need to add them all up. So when you're doing this arc length, just remember what the formula is. I want the rate of change on this. So this is x prime of t, because you're going to add it up. Y prime of t. Because remember, if I want the position, what do you do with the position? You integrate the velocity, right? So I'm going to use the velocity, and then I'm going to add them all up. And so this is going to be L is equal to the square root of x prime of t squared. I prefer to write it this way. Y prime of t squared. Because when I do the position, remember when I get the position? This is one I thought I should have prepared. When I do the position, it's the integral of the velocity, right? And you add up all the little velocities. So these are little velocities. And so when I add that up, that's why I said it's going to have to do with velocity here. That gives you the length of the arc if I do what with this? This actually right now is the velocity. That's your piece. So that's right, remember? Your position is equal to the rate times time. Yeah, so we integrate it. So your velocity is this, and if I integrate my velocity, I get my length of my arc. So I'm going to integrate from t1 to t2 of this square root. Yeah. When they want the speed, this gives you the speed. You have to have the velocity.
Doesn't that give you what's going to happen? Just like it was the same thing as before.
Yeah, that's what I want. I want the length of the arc. What's the velocity? This is the velocity. Sorry, I should have a dt here. So the velocity is just this. It's the square root of dx dt squared. I can write it a little differently. Plus dy dt squared. And if you integrate the velocity, you get the length of the arc. Right? That's the velocity equation. Now that's going to be the magnitude. That's your speed. So that's all we have there. It's right there. That's the formula.
So how did, do we use this for parametric or just a curve?
Would be they didn't give you parametrics last year.
How accurate would that be?
It's exact.
Wouldn't the line be like something that's just straight line?
Yeah, you're going to make these little segments teeny tiny. Well, that's what the integral does. You don't have to do that. So just using the formula, I want the length of this arc between 1, 1 and 4, 8. And I said graph this first. Well, I think I'd rather get a new graph. How about you? Because I don't have any motion here.
Get all that cast.
No, the cast doesn't have any motion to it, unfortunately. That's the reason why I don't. That's the thing I don't like about it. So we're going to change to parametric mode. Remember how to do that? Well, there are programs. They're called TNS files, but that does it. Okay, so I want to clear that out and clear this one out. No. T squared.
Yo, what up, Vader?
And then this is T cubed.
Be like, hey yo, this is shout out Vader.
Vader, this is the
She
good
says
stuff.
Justin though. She never says Vader.
Yeah, give a shout out to Justin.
I want this to be just I want the circle trace. Okay, and I want the points 1, 1, and 4, 8. So on my window, I'm going to make sure I'm going to get that. X will be within that. 4 and the Y value has to go up to 8.
It's only ring like 3 times.
Okay, you ready?
Twice, and then it doesn't ring like 8 times.
So it's coming up here. Let's change the Y value to be negative 10.
Okay, if he doesn't pick for Kevin, he's obviously not going to pick up the expected. No.
Well, it's really fast. So let's change this T-step to 0.01.
Because this flows to what?
Like a boyfriend and a girl.
There we go.
Oh, dude. Play out this.
Okay, so it's coming in this way. And it's going to come in here, then it's going to do this. I need to find the times. These are the X values. This is always the hard part, is finding the time. 1 is equal to T squared, that's the X's, and 1 equals T cubed. This gives me 2 answers, 1 and negative 1. This gives me only 1 answer. So what T value do you want? T equals 1. Okay, Marcus? Okay, what's the other one? 4. 4 equals T squared. That gives me 2 answers, 2 and negative 2. And 8 equals T cubed. You have to check both of the equations. So T is equal to 2. So we're going to integrate from 1 to 2. Not usually, because it's in that square root. So it's usually going to be in the calculator section. So it's the square root of, it's dx dt squared. What's dx dt? 2t. So it's 2t squared plus, and then dy dt equals 3t squared squared, and then it's a dt. And if we simplify that, it's the square root of, and I think this one can be done by hand, but not usually. And it doesn't hurt us to look at this algebraically. Or does it? What could you factor out of both of these in the square root? Okay, so it's 1 to 2. If it's in the calculator part, no. If it's in the non-calculator part, you'd have to do this. This is t squared, and I'm still left with 4 plus 9t squared. I just want to show you that this one can be done, but it's very hard usually to do these because of that square root. What's the square root of t squared? T. And yet, guess what you would have to do to get this to work? A U substitution. Now, why is it going to work?
No, we'll be fine. Put it on your
Yes. Why will it work? Because if you let U be equal to this,
Yeah, then it'll equal to E.
so du equals 18t dt, so I'd have a 1 over 18 out here. Then, of course, you'll remember to change the 1 and the 2, right? When t is 1, this is 13. When t is 2, 40. Oh, I know. That's okay. We're not going to do it. but this would be u to the 1/2. But it's rare that you're going to be able to pull something out and get a u substitution to work. You're going to have sines and cosines and things like that. So that's not going to happen. Now, there are other versions of this, and this is what happened last year. If you are given not the parametrics, but the Cartesians, it looks like this. It's the integral from a to b, which those are the x's now. So it's 1 plus dy dx squared, or if you have it in terms of y, it's dx dy squared. Okay, Matt? And we'll do this problem, and then we'll do last year's problem, because you guys all have your packets with you. X and Y's. And Cartesian coordinates comes from Descartes.
Can I go to the cafeteria and grab my package? Yes.
I think he's serious.
I know well, no, he's not that serious. Descartes is a French mathematician, and he's the one that decided we'd graph this way, X and Y's. That's why that's a Cartesian coordinate plane. Okay, here it is. Estimate the length, forget the homework, well, I don't know if it matches. If this matches, fine. Whatever's on the assignment sheet. Estimate the length of the portion of the hyperbola xy equals 1, so y is equal to 1 over x, from the point 1, 1 to the point 2, and then 1/2. So do you want to do dy dx or dx dy? Okay, so what's dy dx? We've memorized this, right? No, that's integral. Hey girls, what's the derivative of 1 over x? Negative 1 over x squared. We've seen that so many times. So L is equal to the integral. It's going to be dx. It's the square root of 1 minus, or 1 plus, negative 1 over x squared, dx from x is 1 and x is 2. And I throw it on the calculator because I can't do it. I don't know how to do that one. Wait, say that again? This is dy dx. These are Cartesian coordinates. There are no t's. So we can do that. We can look at 2011. Last year's. That's it. Yeah, you should have a 2011 packet.